Hey math enthusiast, I'm here to go over some problems from section 6.1 and 6.3, which deal with ratio, proportions, and similar figures. First couple problems are just asking us to simplify the ratio. But the first thing I need to do is get them in the same units. Alright, if you remember, the rule of thumb is always change them into the smaller units. So I'm going to keep the top as 8 inches, but I want to change this 3 feet into inches. Well, there's 12 inches in 1 foot, so there's going to be 36 inches in 3 feet. Then we just want to reduce that as much as possible. So it looks like we can do 2 to 9 inches. For the next problem, I want to change them both into quarts. So in 3 gallons, there are going to be 12 quarts. To 27 quarts. And last thing I want to do is reduce that. Looks like we can divide them both by 3, which is going to give me 4 quarts to 9 quarts. Last one, my smaller unit is ounces. So I'm going to change this 2 pounds into ounces. There's 16 ounces in 1 pound. So that means there's 32 ounces in 2 pounds. So I have 28 to 32. You can divide them both by 4, which gives me 7 to 8, and my units are ounces. For this next problem, we're given an extended ratio, 2 to 7 to 9, which represents the angles in my triangle. Well, in this case, I know that they have to add up to 180, and I know it's going to be some multiple of 2, some multiple of 7, and some multiple of 9. I don't know what that is, but I'm going to set up an equation to try to figure that out. So we're going to have 2x, 7x, and 9x. Looks like after I add all those up, I get 18x equals 180. So it looks like in this case, x equals 10. Now if x is 10, I'm going to go back to my extended ratio, plug that in, and it looks like my angle measures are going to be 20, 70, and 90. And if I reduce that, then I go back to what I originally had, 2, 7, and 9. For this next problem, I'm dealing with an isosceles triangle. So we'll sketch one out over here. It's isosceles, so I know my 2 legs are congruent. I also know that these base angles are going to be congruent. So for this problem, they give me a ratio of 7 to 4. So that's the vertex angle to 1 base angle. So vertex to a base. All right. Now, in this case, we do have 2 base angles. Remember, we have one down here and one down here. So I can actually extend this ratio to be a vertex angle to base angle to base angle. All right, so my ratio would change from 7 to 4 to 4 to represent the other base angle, since I know those 2 are equal. Well, now this problem is just like the last problem. I know my angles are going to add up to 180. I know one of them is a multiple of 7, one of them is a multiple of 4, and then obviously the last one's a multiple of 4 as well, since it's also a base angle. So now I'm just adding everything up. We end up with 15x equals 180, and x equals 12. Last thing I want to do is take that x value and plug it in to figure out my 3 angle measures. So it looks like it's going to be 84, 48, and 48. So my base angles are both 48 down here at the bottom, and then my vertex angle up top here is 84. So remember, if I go back and reduce this, I'm going to end up with 7, 4, and 4. For this next problem, I'm still dealing with an extended ratio relating to a triangle, but now it's dealing with the side lengths. All right, and the clue they give me is the perimeter. So I know the perimeter is going to equal to 420. Now, to figure out the perimeter of my triangle, I'm going to have to take those three side lengths and add them up. Now, once again, my side lengths are not 7, 9, and 12. All right, but there's some multiple of 7, some multiple of 9, and some multiple of 12. And I know if I add up those three side lengths, they're going to give me the perimeter. All right, it's not 180 in this case because I'm not dealing with angle measures. All right, but it's 420 because that's the perimeter that they give me. Okay, so now I'm going to go through, add these three up. Looks like we end up with 28x equals 420. And x equals 15. Last thing I have to do is plug that x into these three values to figure out what are my actual side lengths. So it looks like it's going to be 105, 135, and 180. And if I just want to check to make sure that's correct, I can take those three side lengths, add them up, and I'm going to get the perimeter that they originally told me. Next problem, we're dealing with the area of a rectangle. So my area equals 384 feet squared. And they give me a ratio for width to length. So I know that the width to the length is 3 to 2. So first thing we got to recall is that my formula for the area of a rectangle is length times width. But it's not just going to be 3 times 2, because obviously that's not going to give me the area that they told me, 384. Okay, so similar to the previous problems that we've done, I know that it's going to be a multiple of 3 and a multiple of 2. So I'm going to take all this information and plug it into my equation. So my area is 384. My length, remember that's the second one listed here, is technically 2x. And my width is 3x. That doesn't make a difference now, but it will at the end when I plug in x and give the width and the length. So we end up with 384 equals 6x squared, because I'm doing x times x. Once I divide by 6, I end up with x squared equals 64. So finally it looks like x is going to equal 8. Technically it's positive or negative 8, but I know I'm only going to be using the positive values in this case. So the last thing they want is what is the actual width and length. So I'm going to take x and plug it in. My width was 3x, so that's going to be 24. My length is 2x, so that's going to be 16. And the units they were using in this case were feet. So that's my final answer. For the next couple questions, you're asked to solve the proportion. I'm going to skip down to D, E, and F because these are the harder problems. So remember, I just need to go through and cross multiply. Now, for this first one, so obviously I'm going to end up with negative 12. But then when I multiply these two, it might help to write it out. So it's a binomial times a binomial. So you have to remember that you're going to have to FOIL in this case. So I'm going to end up with x squared plus 3x minus 5x minus 15. All right, so I have an x squared, I have an x, I have a constant. It looks like I'm going to have to factor. So I'll get all my terms over to one side. I'm going to move this 12 over. So I'm going to end up with x squared minus 2x minus 3 equals 0. So last thing I need to do is just try and factor this. So I know it's going to be x and x. I need factors of negative 3. They're going to add that negative 2. So it looks like that's going to be negative 3 and positive 1. So my final solutions can be positive 3 or negative 1. And the last thing they want you to do is just check your solutions. So if I plug in we'll start with 3 first into my proportion up here. I'm going to end up with negative 2 over 4. And that should be equal to negative 3 over 6. Works out. Next one I'm going to try out is negative 1. So I'm going to go back to my original proportion. If I plug in negative 1, I'm going to end up with negative 6 over 4. And is that going to be equal to negative 3 over 2? Looks like it works out. So both of them are correct. So for this next problem, for e, when I cross multiply, looks like I'm going to end up with 20. Now this is similar to what we had last time in d, but my signs are switched. So when I FOIL this, I'm going to end up with x squared plus 5x minus 3x minus 15. So I'm still going to have 20 on this side. When I combine my terms, we're going to have x squared plus 2x minus 15. So now, once again, I want to try to go through and factor this. When I put it into standard form, I'm going to have x squared plus 2x minus 35 equals 0. So now when I set it up to factor it, remember I'm looking for factors of negative 35. They're going to add to positive 2. So let's go with positive 7 and negative 5. So it looks like x can equal negative 7 or positive 5. So the last thing I want to do is plug these back into my proportion and check to see if they work. So let's start with negative 7. So if I go back and plug it into my proportion, I'm going to end up with 4 over negative 10. And then that should be equal to negative 2 over 5, which looks correct. All right, those two are equal. Next one I'm going to check out is 5 to see if that works. So I'm going to end up with 4 over 2 is equal to 10 over 5. And it looks like that one works as well. Last problem for f. This one's obviously a little bit more complicated. So I'm going to have 3 times 4x, or 3 minus 4x times 2 plus 3x. Then on the other side, I'm going to have 1 times 1 plus 5x. So once again, I'm going to have to FOIL. So I'm going to end up with 6 plus 9x minus 8x. And lastly, minus 12x squared. And on the other side, I'm just going to have 1 plus 5x. So once again, it looks like I'm going to have to FOIL. Since this is negative right here, I'm going to choose to move that 12x squared to the other side. So I'm going to try to move all these terms over to the right. So that's going to give me positive 12x squared. Looks like I'm going to get plus 4x, and then it looks like minus 5 equals 0. Now, when I go through to factor this, first thing I would focus on is the negative 5. I really only have 2 options for that. It's going to be 5 and 1. I'm not really sure where my signs are going to go yet. All right, but now I want to jump back and focus on that 12x squared. So my options would be 12 and 1, would be 6 and 2, and 4 and 3. After some guessing and checking, I'm going to go with 2 and 6. All right, now I know when I go through and FOIL this, in the middle, I'm going to want to end up with 10x minus 6x, because that's going to give me that positive 4x. All right, so in this case, I know I FOILed it or factored it correctly. Last thing I need to do is just pull out my solutions. So it looks like x can equal positive 1/2, or x can equal negative 5 over 6. So let's clean all this up, go back, and try to check our answers. So first let's focus on that positive 1/2. So I'm going to go back to my proportion. I'm going to replace x with positive 1/2. So we're going to get 1/2 here. 1/2 here. And it should be equal to 1/2 plus 3 times 1/2. Now in this case, since we're just checking it, it is okay if we change some of these into decimals. So it looks like I'm going to end up with 1/3.5. And on the right hand side, I'm going to end up with 1/3.5. Alright, so it looks like that is a valid solution. Now I'm going to go back and check -5/6. So I'm going to do the same thing. I'm going to go back and replace all my x's with -5/6. This one's probably not going to be as nice as the other one. Now this one's definitely going to be a little bit messier. I end up with 6.3 repeating over -3.16 repeating. And then this is supposed to equal 1 over -0.5. Right. Now if it helps, it might just be easier to change both of these into decimals. So plug them into your calculator as is and see what decimal you're going to get. Alright, it looks like both of them are going to end up being -2, which shows me that this is a valid solution. So both positive 1/2 and -5/6 do work for this problem. Next problem deals with geometric mean. Alright, remember how to set up your proportion to find geometric mean. So a over x equals x over b, where a is 10 and b is 40. So I would just have 10 over x equals x over 40. So it looks like x squared equals 400, and in this case it looks like x equals 20. For the next problem, they start me off with my similarity statement. Now, in some cases, it doesn't hurt to draw a little picture. All right, so you have triangle CAT, which is similar to DOG. Picture doesn't have to be drawn to scale. It'll just help us visualize what's going on. And then label everything you have. So DO is 4, CA is x, CT is x plus 2, and DG is x plus 6. So obviously I can see the sides that correspond to one another based on the way I drew my triangles and labeled them. So what I'm going to do is set up a proportion. I know x over 4, that ratio should be equal to x plus 2 over x plus 6. Now, just to point out, you could have set up your proportion x over x plus 2 equal to 4 over x plus 6. Alright, when I go through and cross multiply, I'm still going to end up with the same thing. So I'm still going to have x times x plus 6, and on the other side I'm still going to have 4 times x plus 2. So it looks like when I distribute, I'm going to end up with x squared plus 6x, and I'm going to have 4x plus 8. It looks like I'm going to have to factor based on the fact that I have x squared, x, and a constant. So I'm going to rewrite this over here in standard form. So I'm going to have x squared plus 2x minus 8 equals 0. So next thing I want to do is just try and factor this. So I'm looking for factors of -8 that are going to add to positive 2. I know I'm going to start with x and x. It looks like we can do 4 and 2, and it's got to be positive 4 and -2. So x is going to equal positive 2 and -4. But it looks like if I go back and check out my picture, the one side, remember, is just x, Well, there's no way I can have a negative side length, so it looks like my final solution is just 2. Last thing they want is the length of each segment. Well, then I can just plug x into each of these and figure out my lengths. For the next problem, they tell us we have a flagpole, cast a shadow. So first thing I want to do is sketch this out. So let's say here's my flagpole, and here's my shadow. Alright, I know the shadow is 28 feet long. And then we have a person nearby. So let's say here's my person. And they cast a shadow that is 8 feet long. And their height is 6 feet. Alright, what I'm looking to solve for is the height of the flagpole. Alright, now these two are similar figures. Alright, so if I complete them, we can say that they're two triangles that are similar. Alright, now in this case, it's just like the previous problem. Alright, match up the sides that go together. Obviously the shadow is going to match up with the shadow. Alright, and then the height that I'm looking for is going to go with the height that I have. So when I set up my proportion, we can do x over 6 equals, and then since I started with x up here, across from that I'm going to have 28 over 8. So it looks like when I cross multiply, I'm going to end up with 8x equals 168. And after I divide by 8, it looks like x equals 21. And my units that they're using are feet. For number 11, use the proportion that they give you. Alright, so let's copy it down here. FD over EF equals CD over BE. Now, what I'm going to do is I'm going to erase these, and now I'm going to replace them with their actual lengths that they give me. So FD in my picture, it looks like is 12. EF in my picture, if I can find my eraser, is 9. Next one, CD is 16. And then for the last one, BE, it looks like we'll just call that X, because I don't know what that is, and that is what I'm looking for. So when I cross multiply, I'm going to end up with 12x equals 144. And when I divide, it looks like x equals 12. So that means BE is obviously 12. For the next problem, they give me my similarity statement, and they give me my picture to go along with it. I'm looking to solve for y. First thing I want to do is just try to match up all the pieces that go together. So I know, according to my statement, that QR, so that's right here, is going to match up with TU over here. And I know that RS is going to match up with UV, according to my statement. Okay, I'm not too worried about the third side because they didn't label it. So let's match up my two sides in red and set up a ratio with them. So 24 over y plus 13. And then this should be equal to the ratio of the blue sides, 39 to 3y minus 5. Okay, so when I cross multiply, it looks like I'm going to end up with 39 times y plus 13. And on the other side, I'm going to have 24 times 3y minus 5. So it looks like I'm going to end up with 39y plus 507. And then we're going to have 72y minus 120. So I'm going to end up with 33y equals 627. And the last thing, when I divide by 33, it looks like y equals 19. Next problem, we have to work backwards. They want two different numbers that will result in a geometric mean of 4. So remember how we set up our proportion for the previous problem. A over x equals x over b. Well, in this case, we have x. I know that it's 4. So I'm going to rewrite my proportion, and I'm going to replace x with 4. So I know in this case, I'm going to have ab, which equals 16. So the question is, what values could I have here for a and b that are going to equal 16? So we could do 1 and 16, could do 2 and 8. Technically 4 and 4 will work. All right, but I was kind of looking for something else because they already tell us the geometric mean is 4. Next problem, they're telling me my two figures are similar, and I'm looking for the parameter of RST. So the scale factor, and this is important, so the scale factor of ABC to RST is equal to 3 to 2. And then they go on to tell me that the perimeter of ABC is 75. So I'm going to set up a proportion, 75 over x, and x represents the perimeter of RST. So it looks like I'm going to end up with 3x equals 150. So it looks like my perimeter is going to be 50, and the units they use, inches. Next problem, they give me my statement, and I'm essentially just matching up parts. Okay, so they want all the congruent angles that go together. So that would be angle A, obviously congruent to angle D. Angle B goes with angle F, and obviously angle C goes with angle E. The other thing they ask for is the corresponding sides in a statement of proportionality. So I want to set up a proportion showing that all these ratios are going to be equal. So I want to show that the ratio of side AB to DF is equal to the ratio of BC to FE, which is equal to the ratio of AC to DE. There's my statement of proportionality. Next problem, they start me off with my similar figures, these two pentagons. And it looks like in my picture, based on the way they mark the angles, that my figures are actually facing the same exact direction. So I can clearly see what side's going to match up with what. So like AB goes with RS, and BC goes with TS. All right, first thing they want is the scale factor ABCD to RSTV. Well, let's start with two sides that we actually have the length of. So let's do AB to RS. So when I replace them with my side lengths, that's going to be 10 to 14. When I reduce it, it's going to be 5 to 7. So now I can use that scale factor to solve for other missing parts. So like for the next problem, RV. So we'll label RV as X in my picture. Now I'm going to use my scale factor that we just got, 5 to 7. And I know X is going to go in the denominator because of how my scale factor was set up with RSTUV being listed second. And it looks like RV corresponds to AE. So to complete my proportion, I'm going to fill in 15. So it looks like I end up with 5x equals 105. So it looks like RV is going to be 21. And for the next problem, they want the length of CD. So we're going to set this one up the same way. I'll call this side Y. I'm still going to use my scale factor, 5 to 7. And for the rest of my proportion, in the numerator, I'm going to put Y because it's coming from figure ABCDE, and that's how I set up my scale factor. And it looks like that side CD is going to correspond to TU. So my denominator, I'm going to have 42. So it looks like I end up with 7y equals 210. So it should be y. So it looks like y equals 30.